We'll start with section 7.1. We will learn about integration by parts. So you all are familiar with the product rule from Calculus 1. So let me restate the product rule. This is from your Calculus 1. Suppose I have product of two functions, say f and g. So f times g. The dot here is the usual multiplication. And we want to derive this function y. So let's do dy over dx. We are deriving with respect to the variable x. So all you do is derive the first function f prime, fix the second function g, don't do anything with that, plus fix the first function f, derive the second function g. So you fix one function and derive the other function. Now let's try to integrate this product rule. So as soon as I say integrate, we write this integration symbol, and we also mention the variable of integration, which is dx. So d over dx from the top, I'm going to bring it to the bottom. So let me write d over dx. And this variable y here, we are differentiating y. So this variable y, I'm going to plug in as f times g. So rather than writing y, let me write this as f times g equals, on the right hand side, I have f prime g plus fg prime. For simplicity, I'm not writing those function of x and g of x and so on. If I write f prime, it is understood f prime is a function of x. If I write g, g is a function of x. So we integrated the left hand side. So we have to integrate the right hand side. So let me write integration symbol, and the variable of integration should be same as the left hand side. So let me write dx. Now we want to read this expression on the left carefully. So when you read this, you write, this is integral of, what is the function we are integrating? Derivative, we see d over dx, derivative, and the term we are integrating is the product term. So you call it as derivative of the product term. So we have a formula for integral of derivative of the product. But we know when we integrate a derivative term, suppose I'm integrating a prime. A prime is a derivative term. I'm integrating a derivative. The answer for this integration is just the function itself, a. So similarly, we are integrating fg. We are integrating the derivative of fg. So when we finish that integral, all we get is just the function. So I'm going to write this as fg. When I simplify this, all I get is just fg. The right hand side function, bring it down and separate the integrals. So this is integration f prime g dx plus integration fg prime dx. There's one more way of writing this. So rewrite the expression. Write these first, bring to the left, and move this term to the right. So integration fg prime dx equals fg minus integration f prime g dx. Now let's rewrite this formula for f and g in terms of u and v. Let me add a page here. Let's rewrite a little bit. Let's write f is a function which is renamed as u, g prime dx, we see these expressions here on the top. G prime dx, we are going to rewrite it as dv. So let's use these two set and rewrite the entire integration formula on the top. So the new integral looks like this. It's integration u dv equals u times v minus integration v du. So for g prime, I write it as dv, but for g, if you note carefully, I'm writing it as v. And for f prime, I'm writing it as du. So here is the explanation for those two substitutions. If the function f is u, if I derive f, I get f prime. If I derive u, I can write it as differential du. Similarly, if I have g prime dx is dv, this is our assumption. So if I integrate this, I have integration g prime dx and I have integration dv. I can write this as g equal to v. So we have used these two substitutions also. So hence we have this expression in terms of u and dv. So what you have to note in all these integration by parts, you have to carefully identify the function u and the function dv. And then you do start using this formula here in the box. This is the integration by parts formula. So let's do an example. Compute the following integral x times e to the 2x. Let me write one more formula here. I call this as I late. I is for inverse trigonometric function, inverse trig function. This looks like sine inverse, cosine inverse, and so on. L is for logarithmic function. A is for algebraic function. X square plus 1, it looks like that. T is for trigonometric. It is like sine theta, cosine theta, so on. E is the exponential term, which is e to the x or a to the x. So there's one more way of integration by parts. You can read this given function in the same order. If you see an inverse trigonometric function, you can name it as the first function. L is your second function, logarithmic. Third is your algebraic. Fourth is trig. Fifth is the exponential. And the order in which you select the functions is from left to right. So now let's read this function carefully. X is the algebraic function and e to the 2x is the exponential function. If we read our ILATE rule, we see algebra leads exponential. So let me name algebraic function as our first function and the second function is exponential function. We just now learned a rule for integration. Integration uv is u dv, uv minus v du. The same rule can be written as integration of first function times the second function dx. One refers to the first function and 2 refers to the second function. You write the first function, integrate the second function, minus a big integral sign, derive the first function, integrate the second function. So you have to read this integral is a product of two functions. Now let's integrate the function x e to the 2x, the given problem, using this rule. This is same as the udv rule which we wrote on the top. After finishing this, let me do the udv rule. So let me replace the first function. The first function in the problem is x. So replace x. Integral of the second function. The second function is e to the 2x. As soon as you write integral, you should write the variable of integration dx minus an integral sign d dx of the first function. The first function here is x, so write it as x. And then integral of the second function, so write e to the 2x dx. If you write this integration by parts rule correctly, all you will see is the entire expression here is the first term, and the entire expression here, this is your second term. You will have two terms after you expand using the integration by parts formula. In that, if you see, you will have a second term integration here, which will be exactly same here in the second term, e to the 2x dx. Now let's integrate this. So first function is x. Just bring this down. Don't do anything with this. Integral of e to the 2x dx. The integration formula says that this integration will be e to the 2x divided by 2. Negative. I have an integration sign. This one. Bring it down. Differentiation of x with respect to x is 1. Integral of e to the 2x, we already did here in our first term. It's exactly the same term, e to the 2x divided by 2. And the variable of integration is dx. Now, as you see, the first term is already simplified. So just bring it down. Let us simplify our second term. This 1/2 goes outside. And now we do this integration of e to the 2x. Integration of e to the 2x is e to the 2x divided by 2. Simplify a little bit. This is 1/2 x e to the 2x negative 1/4 e to the 2x. So when you choose the first function and the second function carefully using the isolate rule, the integration by parts rule says write the first function, integrate the second, minus a big integral sign, differentiate the first, integrate the second. This is exactly same as the udv rule which we wrote on the top. Now let me do the same problem using this udv rule. So first let me write the rule, and let me write this as a method 2. This is the udv rule. So the udv rule says this is u times v after you integrate minus integration v du. The one what I did here is the method 1. I call it as isolate method. Isolate, I stands for inverse trigonometric, L for logarithm, A for algebraic, T for trigonometric, E for exponential. Again, both the methods are the same, just the way you interpret them is a little bit different. So in this method 2, the udv rule, we have to identify u and dv carefully. So let me make columns for this. Here is the problem. The integral of x e to the 2x dx. We are trying to evaluate this integral. So the first function is u, which means we assume it to be x. The second function, the integral function, is e to the 2x dx. So let me write d here, d for differentiating. You will differentiate the first function. I for integration. You will integrate the second function. So now let's differentiate x. You get 1. Differentiate 1. You get 0 and you stop. integrate e to the 2x dx. It is 1 half e to the 2x, and then integrate 1 half e to the 2x, you get 1/4 e to the 2x. Now let's plug in these functions back to the formula. So we have uv, u is x, v will be 1 half e to the 2x. The very first time you integrate the dv, you get the function v. So let me write, this is 1 half e to the 2x negative 1/4 e to the 2x, and then the last term will be 0 times 1/4 e to the 2x dx. After you plug in these functions to the formula, you have to integrate one more time to get this step. Simplify this. Or you can write this expression here directly from the table. So if you want to write it directly from the table, all you do is multiplication of the terms in this table. Multiply x and 1 half e to the 2x and choose a plus sign for the entire term after you multiply, and you're seeing the term here, x times 1 half e to the 2x. In the next step, multiply 1 with 1/4 e to the 2x. When you multiply these terms, you write negative sign, and you're seeing that term here, negative 1/4 e to the 2x. And lastly, for the last term, what you do is multiply these two terms, and the sign of the term will be plus. After you multiply, you have to integrate the terms, and you're seeing this term here. We multiplied 0 and 1/4 e to the 2x. The sign of the term is plus, and then we are integrating it. When you simplify, you get this to be your final answer. So this is one way of doing the problem, where you identify the function u, dv, evaluate the differentials, integrate the function, and then plug in back to the formula and simplify. Whenever you integrate, because this is an indefinite integral, you don't have the limits of integration, you make sure to write a plus c, constant c towards the end. Same way in the method 1, we should write a plus c in the end, because we don't know the definite answer. This is not a definite integral. So c is the constant of integration. So let's do one more example. Let me do the isolate method, where I select the functions and integrate. Now I see x square is an algebraic function. Here is algebraic function. So this leads the given functions in the group. Then I have the exponential function. Exponential comes in the last. So I'm going to give you the preference as second function. So the rule says when you have two functions, 1 times 2, first function times second function, and then you have a dx. All you do is write the first function, integrate the second, minus a big integral sign, differentiate the first, and integrate the second. Read this as product of two terms, differentiate the first, integrate the second, and you are multiplying the terms, and the entire product is being integrated. So let's do this. Let me plug in the first function. We decided our first function is x square, algebraic. So let me write x square as the first function. Integrate the second function. So integrate exponential 2x dx minus integral of differentiate the first function. When you differentiate, the first function, it looks like this: d dx of x square. Integrate the second function, e to the 2x dx. This integral has a sign dx. For the entire integral, you have to write one more dx. Now, let's simplify this. Bring down the x square. Integral of e to the 2x is e to the 2x divided by 2 minus integral and dx. So bring down this integration here and this dx here. So d dx of x square, simplify this term. You are differentiating x square. When you differentiate x square, all you get is 2x. And simplify this term, integral of 2x dx, you already did here in the first term. It is e to the 2x divided by 2. Now carefully read the second product here. This is the product of terms. You can cancel these two. So rewrite the term x square e to the 2x divided by 2 minus integral x e to the 2x times dx. Now again you see this is the product of two functions. The first one is the algebraic function. The second one is the exponential function. You have to do integration by parts once again. So let's do that. X square e to the 2x divided by 2 minus, open a big square bracket. This is for the second term simplification. First term is x. Integrate the second function, e to the 2x divided by 2 minus integral of, differentiate the first function 1, integrate the second function e to the 2x divided by 2, and then a dx. Now simplify these terms, also multiply the negative sign outside. So this is x square e to the 2x divided by 2 negative x e to the 2x divided by 2, and when you multiply the negative sign and integrate, you get e to the 2x divided by 4, and then a constant of integration plus c. The next problem, I'll use the method 2, which is the formula method. Integration u dv is uv minus integral v du. So let's do by the formula method. Let me identify this function as a differentiation function, and the one with the dx is your integral function. So make two columns, d slash I. D is x cubed plus 6x. Integral function is sine 2x dx. Keep differentiating the first function until you get 0, and then you can stop the table. Differentiate the first function, 3x squared plus 6. Differentiate again, 6x. Differentiate again, 6. Differentiate once more, you get 0, and then you're good to stop. Now integrate sine 2x, you have negative half cosine 2x. Integrate again, negative 1/4 sine 2x. Integrate again, 1/8 cosine 2x. Integrate again until you get a term for the last row. You get 1/16 sine 2x. You don't integrate again because you already have a 0 on the left. So when you do the product, the entire term becomes 0. Now, the rule of writing the expression says that multiply crosswise like this and choose a plus sign for the first term. Multiply again crosswise, choose a negative sign. Multiply, 6x with 1/8 term and then a plus sign. It's alternative plus and minus. Multiply 6 with the 1/16th term and you have a minus sign. The last term, when you multiply 0 and 1/16th, anyways you get 0, so you don't write the term. So let's multiply out the terms and write the integration. So integral x cubed plus 6x times sine 2x dx. When you multiply the first term, you have negative half x cubed plus 6x cosine 2x. Multiply the second term, you have 3x squared plus 6 times sine 2x divided by 4. Then you have 6x divided by 8 cosine 2x. And one last term, 6/16th negative term sine 2x. And then a constant of integration plus c. Let's do one more example. Integration of ln x dx. You need two functions, the product of two functions, if you're doing integration by parts. Suppose you have just one function ln x, you want one more. So if you want one more, all you can do is write the same function as times 1. When you do this, you will have two functions. So let's make a table for d and I. The function d, what we assume is ln x, I is 1. So let's differentiate ln x, we have 1 over x. Integrate 1, we have x. So in this choice, suppose we choose d is 1, then we find the d prime, you get 0. And the possible choice for I will be ln x. But if you try to integrate ln x, we don't have an ln x integration formula. So we'll not be able to choose d is 1 and I is ln x. So the only choice, d is ln x and I is 1. So this fails. So we go for d ln x and integral is one choice. So now let's plug in these in the formula. You have just one step. These two are multiplied plus, and when you multiply these two, you have a minus and integral sign. So integration ln x dx is x times ln x. We are doing the product of the cross terms from the table. Negative integration 1 over x times x dx. Cancel these terms. X ln x negative 1 dx. X ln x negative x plus c. The next one is integration x square ln x square. So let's make a table d and I. The first term is ln x the square. The second term integral is x square. So let's do a chain rule for this differentiation of ln x square. Use the power in the chain rule. So this is the power rule, 2 times ln x. Now differentiate ln x again, you get 1 over x. Integrate this term on the right hand side, x square, you get x cubed divided by 3. Multiply the terms with a positive sign, multiply these terms with a negative sign, and then integrate. So we have x square ln x the square dx equals x cubed divided by 3 ln x square negative 2 ln x divided by x times x cubed divided by 3 dx. If you observe carefully, you can cancel these exponents, make this as 2. X square x cube ln x square divided by 3. Though the term looks messy, there's nothing to simplify, so leave it as such. Don't do anything with our first term. Let's simplify our second term. 2/3 go outside, constant of integration, ln x times x square dx. Now again, if you observe carefully, it's a product of two functions, and you have to choose integration by parts again to integrate this function. So let's do that. Make a table for the differentiation function and the integral function d and I. We choose ln x as the differentiation function. Differentiate once, you have 1 over x. X square is the integral function. Then integrate, you have x cubed divided by 3. The first two examples, if you had seen carefully, when we choose the differentiation function, we keep differentiating until you get 0. But the third problem, when we started with the ln x function, we are not differentiating the first column until 0. The reason is, if you differentiate this, all you get is negative 1 over x square. Again differentiate, negative 2 over x cube. No matter how many times you differentiate, you will never get 0 in the end. So you cannot keep differentiating always. So you stop at the very first differentiation. So now let's plug these in the UDV formula. Plugging into UDV is same as you identify the terms, multiply them with a plus sign, and then multiply these two terms with a minus, and then integrate. So integral of this term here, x square ln dx. This is what we are working now, the last term, x square ln x square. This is the entire given problem, dx. We got this to be x cube ln x square, this term here. So let me bring it down. X cube divided by 3 ln x square. Now this integration by parts for ln x x square from this table, we have negative 2/3 outside. Then now let's use the table here. X cube divided by 3 times ln x, negative 1 over x, x cube divided by 3 times dx. Now let's simplify this a little bit. Cancel x, cancel the cube, write it as square, and multiply this negative for both the times and integrate the last term. So when you do this, you get x cube divided by 3 ln x square negative 2/9 x square ln x plus 2/9 x cube divided by 3. When you integrate x square, you have x cube. And then the constant of integration will be a plus c. This should be cube. It's from here. The next one, x times tan x square. So let's write a trigonometric formula for tan square x. Tan square x is also secant square x minus 1. And integral of tangent x is natural log of secant x. So now let's fix the differentiation and integral formulas. D slash I. Differentiation function is x. Differentiate 1, differentiate again 0. This was not a natural log function, so we could differentiate until we get 0. If it's algebraic function, your differential function, you can differentiate until you get 0. If it's any other function, even though you differentiate any number of times, you will not get 0. So you can stop after first step. Tan square x is our second function, dx, and we want to choose the secant square x -1 formula for this. Now let's integrate this. Integral of secant square is tan x. Integral of 1 is x. Now let's integrate again. Integral of tan x is ln secant x. Integral of x is x squared divided by 2. So now we know the formula. Multiply crosswise, plus sign. Multiply crosswise, the second term will have negative sign. And then multiply these two terms. After you multiply, you choose integral. You want to integrate the terms. So now let's write x tan square x dx. This is the given problem. From the table, after cross multiplying, we have x times tan x minus x negative ln secant x negative x square. When you multiply by 1, this is how the terms look. The last term, the 0 times the last integrated term, 0 times anything is 0, so you don't have to show that multiplication, plus c. So this is our final answer for this problem. The next one is arctan. Arctan is same as tangent inverse function. One more name is arctan. So choose the d and I, the differential and integral terms for this. You have only one term tangent inverse, but you want two terms when you do integration by parts. So write the second term as 1 and then dx. So write the first term is arctangent and the second term is 1. So differentiate this, you have 1 over 1 plus x square. Integrate 1, you have x. Now you have 1 over 1 plus x square. If you keep differentiating this, you understand that this will never go to 0. So you can stop this table, multiply the terms positive sign, multiply these terms negative sign, and integrate. So let's do this. The problem is arctangent x dx. You're trying to integrate this equals, from the table, you can write arctan is multiplied with x, and then you have a negative sign, integral x divided by 1 plus x squared. You multiply the bottom terms times dx. Now you want to integrate x over 1 plus x squared. So to do this, let me multiply 1/2 outside and then 2 on the top. So all I'm doing is multiplying and dividing by 2. When I do this, the integral looks like this, 2x divided by 1 plus x squared dx. Well, in the same step, if you cancel 2, you're going back to the previous step. So it is okay to multiply and divide by 2. I do this because I identify the second integral is a natural log formula. Look at this denominator term carefully, 1 plus x squared. If 1 plus x squared is u, let's differentiate. This is 2x dx, this is du. If the numerator in the problem is the exact differential of the denominator, all you do is that integral will be natural log of denominator, 1 plus x squared. That's the reason I multiplied and divide by 2. Bring down the first term, arc tan x times x. Multiplying and dividing by 2 can also be done by a u sub rule. You get 1/2 ln 1 plus x squared. And then for sure you will have a plus c. And the formula I have used is this: u prime on the top, u is on the bottom. Such an integration is always ln u, the denominator. The next one is sin x times cosine 3x. So far we have been having combinations like trigonometric times algebraic, or algebraic times exponential, or algebraic times logarithm. But this time you're seeing both or trigonometric times trigonometric function. So these type of problems are called as loop problems. The integration keeps going. This never stops. So at some point you have to stop the integration and rewrite that the given integral is renamed as j, integral j, and then you finish the integration. So the starting looks the same. So let me make two columns, d and I. The first function I assume to be cosine 3x. The second function is sin x dx. Now differentiate the first function. We have negative 3 sin 3x. Differentiate again, negative 9 cosine 3x. Integrate the second function, negative cosine. Integrate again, negative sine. So now we know the rule for the table. Multiply these terms plus sign, multiply these terms negative sign, multiply out these last two terms with a positive sign and integrate. So let's write the first step. The problem we are trying to integrate is sin x cosine 3x dx equals, when we multiply the first term from the table, we have negative cosine x cosine 3x, then we have negative 3 sin 3x sin x, then we have positive 9 integral cosine 3x sin x dx. Now if you carefully see, this expression was a given problem, which we restated as integral j. And somewhere on the right hand side, if you see, the last term is exactly same as the integral we want to evaluate. So this is also integral j. Just the product term is different. Rather than writing a times b, you're writing b times a, but the product is still the same. So what you want to integrate is also there on the right hand side. So now you will replace the common integrals by the term j. So j equals negative cosine x cosine 3x, negative 3 sin 3x sin x, plus 9 times j. Now this becomes an algebraic equation. All you're trying to do is solve for j. So add a negative 9j on both the sides. Get rid of this 9j on the right. Simplify the left hand side. You have negative 8j, and then you have negative cosine x cosine 3x, negative sin 3x sin x. You want to find the integral j. That was the question. Integral of sin x cosine 3x was renamed as integral j. So divide by negative 8 on both the sides. So you have j equals negative 1/8 negative cosine x cosine 3x, negative 3 sin x sin 3x, and then you have a constant of integration plus c. And j was the integral what we had to find, which was integral sin x cosine 3x and then a dx. The next one, sin x times exponential 3x. This is also a loop problem. You will see a loop, which means the integration keeps going. So at some point, you will identify the term, the given integral as j. You're renaming the integral. So let me make two columns, d and I. The first one is the sin x column. The second one is e to the 3x. Differentiate the first term, cosine x. Differentiate again, negative sin x. Integrate the term on the right, e to the 3 divided by 3. Then you have e to the 3x divided by 9. If you keep filling the rows of the table, this keeps going. So you stop at some point and you multiply the terms with the positive, negative, multiply these two with the positive, and then integrate. So let me write, the term we are asked to integrate is sin x e to the 3x dx. So from the table, we know what terms to multiply. So let me multiply sin x e to the 3x divided by 3 negative cosine x e to the 3x divided by 9, and then the last two terms negative 1/9 sin x e to the 3x dx. Now you stop at this point and observe the given integral. We renamed the integral as integral j, sine times exponential 3x. And you see here we have sine times exponential 3x and again sine times exponential 3x. So rename this entire integral here as j. So this becomes an algebraic equation now as soon as you rename. So this is j equals sin x e to the 3x divided by 3 negative cosine x e to the 3x divided by 9 negative 1/9 j. So you can add a positive 1/9 j on both the sides to get rid of this negative term on the right. So 1 plus 1/9 will be 10/9, and you flip the term. 10/9 you multiply by 9 by 10 on both the sides. So you can take this on the right hand side and rewrite this as 9/10 and this entire expression sin x e to the 3x divided by 3 negative cosine x e to the 3x divided by 9, and then you have a plus c. So one last example in this section. X cubed times sin x squared dx. Though you see product of terms and you might think this is integration by parts, a substitution will reduce the problem before you do any integration by parts. So let's say y equal to x square. Differentiate, you have dy equal to 2x dx. This is your substitution. Use substitution rule from your calculus 1. Rename this as 1/2 dy equal to x dx. Use this u sub back in this problem and rewrite the problem. X cube sin x square can be written as x square sin x square and then times x dx. So carefully observe the x cube term. I have split it as x square times x. That can be done. You're breaking the multiplication. Exponent terms. And now you know that the first x square by the assumption is y, and then sin x square becomes sin y, and x dx you derive by the sub rule. This is 1/2 dy. Now bring that 1/2 outside. You have y times sin y dy. Now carefully observe, this is your UV rule, the integration by parts UDV rule. So let me make two columns, d and I. The first function is y, the second function is sin y dy. So let's start differentiating the first function, 1 and then 0. Integrate the second function, negative cosine y, integrate again, negative sine y. So let's multiply in this way, the cross way, plus sign, multiply again, minus sign, multiply out the last terms, positive sign, integrate. But you're multiplying with 0, so the term will be 0. So you write this is 1/2 y times negative cosine y plus sine y plus c. Now you can rewrite this as 1/2. I'm replacing y by x square because that was the assumption what we made. Negative x square cosine x square plus sine x square plus c. And that's it. So we have discussed two methods. One is the isolate method where you choose the function to integrate first or second and then you do. This was the first method. The second method was the UDV rule. So it's up to you. Choose the best method which you understand, and integration by parts is really important. You will see this several times in the next few sections. So we'll stop this lecture here.